So up to this point, we have been limited to find our trig functions within a triangle, but mathematicians a long time ago decided, hey, we need to be able to find trig functions for lots of different things. So we need to find some rules to do it outside of a triangle. And that's what this first part is about. Now, we will have a memorization quiz by the end of the week. I am letting you know on Friday we will have a memorization quiz about the lesson we're going to talk about tomorrow. But just know this course requires memorization, and there will be no calculators on that quiz tomorrow. Okay. So anyway, or on Friday. So let's do part one today. How can we find the values of the trig functions for any angle, for any measure, for any spot on a Cartesian plane? So let's not limit ourselves by a triangle. Okay, so please make yourself a little XY axis. And then, this is your X axis. This is your Y axis. In one of the lessons last week, we did kind of look how an angle moves around the XY plane. Remember, this is quadrant 1. Everything here is positive and positive. Both the X and the Y are positive. This is quadrant 2. The X's are negative and the Y is positive. This is quadrant 3. I don't know why I went from Roman to, anyway, everything here is negative, both your X and your Y. And this is quadrant 4. And here our X's are positive, but our Y's are going down, our Y's are negative. So remember, it goes counterclockwise, and many times if we draw an angle, that's your terminal side. The other side that rotates will rotate backwards. So here's quadrant 1, positive, positive, quadrant 2, quadrant 3, quadrant 4. Now let's take a look at how we draw a triangle as kind of the placeholder for our information so that we can... So we need to know how to reference what's our opposite, adjacent, and hypotenuse within the coordinate plane. So let's show you how you do this every single time, okay? So let's say we are at some point, it doesn't matter what, some point in the first quadrant. So the first step is you find your point. The second step is we are going to connect that point to the origin. So let's do our second step here. So we've got this point, we're going to connect it to the origin. Third step is we're going to connect it to the x-axis. So now we're going to connect it to the x-axis. Make a little 90-degree angle there to kind of show you. So we have a triangle now, okay? And then after you connect it to the x-axis, the last thing we're going to do, oh no, we're going to do 2 more steps. We're going to label our theta, and it's always right by the origin. So you connect it to the origin, you connect it to the x-axis, you label your theta. And then the fifth thing, we're not going to do until we get to our examples later. The fifth thing we're going to do is we're going to label our sides. Okay, so we don't have a point for reference here, but we would label the sides, and I'll show you how to do that. So every time we do this, we want to do those 5 steps. So let's say we're in a point at quadrant 2. Let's practice building a triangle in quadrant 2. So we're going to connect it to the origin. We're going to connect it to the x-axis. We're going to put in our theta, and if we had the chance, we would label the sides. We'll do that when we get to an example, okay? Let's practice if we're in the 3rd quadrant. So we'd find our point. We would connect it to the origin. We would connect it to the x-axis, put in our little 90-degree angle mark, put in our theta. So that's what a triangle looks like if we were in that location. And let's do one more. Let's say we're over here. If we're in our fourth quadrant, connect it to the origin, connect it to the x-axis, put your angle mark, put your theta by the origin, okay? Now, as far as the labeling the sides, every single one of these triangles has something in common. The adjacent side is always our x value. The opposite side is always our y value. And for the first time, a triangle could possibly have a negative value listed for its side, okay? So again, our x is going to always be our adjacent. Our y is always going to be the opposite. And so that leaves us with our hypotenuse. And our hypotenuse, you're always going to use the Pythagorean theorem. Okay, so if you can see what we just did there, this lesson should be very nice for you. Okay, so we're going to find the point. We are going to connect it to the origin. We're going to connect it to the x-axis. We're going to label the right angle and label our theta, and then label the sides. Okay. So we call that triangle we find a reference triangle. We call that triangle we find the reference triangle, okay? So you'll notice the x is our adjacent, so that's why we see our cosine. And I don't know why I didn't go in the order we normally do. Sorry about that, but our cosine is x. Our tangent has an adjacent in it. It has an x in it. Our y value is always our opposite. So you see that within the sine and within the tangent. And then our r value happens to be our hypotenuse. And we see that hypotenuse in our cosine and our sine. And then, of course, these are the reciprocals. The reciprocal of our cosine is our secant, so it's r over x. The reciprocal of our sine is our cosecant. The reciprocal of our tangent is our cotangent. Now remember that hypotenuse just is the square root of x squared plus y squared, because this is the Pythagorean theorem. Remember, if you have a right triangle and you know two sides of your right triangle, you can always find the third using the Pythagorean theorem. The hypotenuse is always a positive value. Wherever it's located, the r is always positive, because we can't we are not doing that plus or minus version of the Pythagorean theorem, because that will consider a length. So this is always positive. The x and the y are not, because it depends on where we're at. Sometimes our x is positive in the first and fourth quadrants. Sometimes our x is negative in the second and third quadrant. Sometimes our y is positive. First and second quadrants will be a positive y, up, going up. But a negative y is down here if we are in the third or fourth quadrant. So this reference triangle and making sure you understand how to build it is going to be so very essential as we go through part 1 of 7.3. Okay. So does anyone have any questions about how we pull out the values from our reference triangle? Anybody have any questions about that? Yeah, I'm not sure why it didn't go in quite the right order there, but so now that we have our what we're looking for as far as how to build that reference triangle anywhere on the Cartesian plane, we need to look at some examples. So once everybody's ready, we will look at an example. Mhm. Yes, it does. No problem. Okay. So it says in our first example, let negative 4, 3 be a point on the terminal side of an angle theta in standard position. Find the exact values of the 6 trig functions of theta. See how it says those exact values? That tells us, hey, you know, we can use a calculator a little bit, but that's like the one we did on the quiz where we wanted the values to be a fraction. We wanted the values to be in rationalized form if necessary, okay? So the first thing we want to do is to find the point negative 4, 3. Remember, the first thing we do is to draw your point. So let's go over and label where negative 4, 3 is. So we would go 4 to the left and up 3. So put your point. Second thing we're going to do is we're going to connect it to the origin. So let's do that. So we're going to connect that point to the origin. So that's always your second step after you've drawn the point. Third step is we are going to connect the point to the x-axis. So we're going to draw a connection to the x-axis. And we're going to put our little 90-degree mark. The fourth thing we're going to do is we're going to label our theta. Now, theta is always the point closest, or the angle that is in relationship to the origin. Technically, the angle we are creating this is really the angle we have created, okay? So, but the reference angle is inside of our reference triangle, which allows us then to connect it with some values, okay? The fifth thing we're going to do is we're going to label our sides. Now we're going to label those sides with the values. We're going to label our sides with the opposite, adjacent, and all that stuff. Okay, so those are the 5 steps we're going to take. We now need to do step 5. Okay, so how do we do step 5? Well, let's go over to our triangle. Now remember, this was the point negative 4, 3. So our x value is negative 4. That's always our adjacent. The y value is positive 3. That is always our opposite. So we need to do math to find the r. That is always our hypotenuse. So r is going to be the square root of x squared plus y squared. Just do the Pythagorean theorem. Make sure you put any negative values in parentheses, because that negative 4 then will become a positive 16. And if you don't do that, you know. So that would be the square root of 16 plus 9, or the square root of 25. You might have already recognized that that's a 3, 4, 5 triangle. Our hypotenuse is always a positive value. So in this case, our hypotenuse is 5. Now that we've gotten that, it's just a SOHCAHTOA problem from here, except for the very first time, we may have some positive or negative values. So we know that the sine is opposite over hypotenuse, which would be y over r. Opposite over hypotenuse, which is y over r. So opposite over hypotenuse in this case would be 3/5. Cosine is adjacent over hypotenuse, which is x over r. So for the very first time, we have a cosine that is negative, so it would be negative 4/5. And our tangent is always opposite over adjacent. In this case, it will always be y over x. Our tangent is always y over x, opposite over adjacent. And in that case, we would get negative 3/4. Now, it's customary to put the negative up at the top. If you wrote 3 over negative 4, that's correct. Just customarily for fractions, we put the negative in the top or out in the front, you know. Now, it's said to find the exact values of the 6 trig functions. So we got 3 more reciprocals to go. So remember, our reciprocal of sine is cosecant. The reciprocal of cosine is secant. The reciprocal of tangent is cotangent. So now we just get to flip over those fractions. And improper fractions are fine for this. Just make sure they're reduced. These ones didn't have to reduce. So this would be 5 over 3. This would be negative 5 over 4. This would be negative 4 over 3. Okay. So it is what we've done before. It's exactly what we've done before, except now we might have some positives or negatives based upon what quadrant we land in. The point negative 4, 3, the x value is negative, so we will end up, anything that uses an adjacent will be negative. So that's why our cosine ended up being negative and our tangent ended up being negative, because they both use the adjacent side. Okay? Everybody good with our first example? Do we have any questions or do we need any clarification on that one? Okay, so that's that example. Let's do example 1b. Okay. So we have this point, negative 3, negative 6. That does say negative 3 or negative 6. We are going to draw it, and then we are going to find the exact values of the 6 trig functions for that. Now, negative 3, negative 6, you might recall negative 3, negative 6 will be in quadrant 4. No, that's quadrant 3. We'll be in quadrant 3. So let's put a dot at that location. Now, how do we build our reference triangle? Well, we are going to connect it to the origin. We are going to connect it to the x-axis. Connect it to the origin, connect it to the x-axis. We always put the theta by the origin. So there's our theta. Last step, let's label our sides. The x's always are adjacent, and in this particular problem, we went over to the left 3, so it's negative 3. The y is always our opposite. We went down 6, you might recall. And then our hypotenuse, we're going to have to use the Pythagorean theorem. So our hypotenuse is always going to be the square root of x squared plus y squared. Make sure, because these are negative values, that you put your x and y squared in parentheses. Okay. So that's going to be the square root of negative 3 squared plus the quantity of negative 6 squared. If you square a negative 3, you get 9. Square a negative 6, you get 36. So that's the square root of 45. Now we want this in reduced radical form. We need it in reduced radical form. So because we have a very limited number of things to look for, if we go the perfect squares before we get higher than 45, that's 1, but that doesn't really count. 4, 9, 16, 25, 36, and we kind of, have to just choose from those values. The only value that goes into 45 evenly out of that list is 9. So think about that as 9 times 5. I can take the square root of 9, but not 5, so that would be 3 radical 5. So let's label that side. Remember, that is your hypotenuse. We have our sides labeled. Now we're ready to actually do our SOHCAHTOA stuff. So that's why it's so important that you had all those memorized. So let's write them in order. So remember, our sine is our opposite over our hypotenuse. So that's going to be y over r, or negative 6 over 3 radical 5. Now, that needs a lot of work. That is not a nice setup. So how could we fix that? Well, 3 goes into 6 2 times. So let's rewrite that like that. Negative 2 over radical 5. And then to rationalize, just multiply by that same radical on top and bottom. So we get negative 2 radical 5 over 5. So I want, when it says exact values, I want it in reduced radical form, no decimals. Reduced radical form and no decimals. Now cosine is adjacent over hypotenuse. So for our reference triangle, that's always x over r. Now, if they don't need us to draw it, technically, when you're given a point, you're given the x. You can find the r just by doing the Pythagorean theorem. And x is going to be negative 3 over 3 radical 5. In this case, 3 goes into 3 one time. That's negative 1 over radical 5. Rationalize by making it radical 5 over 5 on top and bottom, which is negative radical 5 over 5. Interesting fact, 1 over the square root of a will always become the square root of a over a. So 1 over radical 2 is radical 2 over 2. 1 over radical 3 is radical 3 over 3. 1 over radical 5 is radical 5 over 5. So and that does always happen when you rationalize it. So I just think it pops to the top and leaves its normal self behind. Okay. Let's do one last one. Remember, tangent is opposite over adjacent. So in this case, it's always going to be your y value over your x value. We were given the y value was negative 6. The x value was negative 3. We're going to get 2 over 1 or 2. Now, those are our three, standard trig functions. So now we have to do their reciprocals. Now let's think about the easiest one to flip over is the one I want to choose. Now I can just flip over the original and go from there, but this is a good one to flip over in this particular case. So that would be negative radical 5 over 2. This is a good one to flip over in this case. So that would be negative radical 5 over 1. When you get a 1 denominator, you don't really have to show it unless you have the urge. This is a good one to flip over, but remember that's 2 over 1, so that's why it becomes 1 over 2. So I like to flip over the reduced version. You don't want to have it in the rationalized form because it's going to bring the square root in the bottom, and you're just going to have to re-rationalize it. So it ends up going right back to where it was before you rationalized. So that is example 1b. Do we have any questions on that one? So draw your triangle by making the point connected to the origin, connected to the x-axis. Label your sides. It becomes a normal SOHCAHTOA problem. The x is always your adjacent. The y is always your opposite. The hypotenuse is found just Pythagorean theorem. We good with that? Okay. Let's look at this one. Now in this one, it did not give us a point, but it told us that the tangent is 5 over 12 and that the sine is less than 0. So let's take a look at really what they told us. If the tangent is 5 over 12, This top number is related to our adjacent. This bottom number is related to our hypotenuse. But if the sign is negative, less than 0, that means that our, nobody, yeah, you need to yell at me. The tangent, let's go back for a moment, I'm so sorry. The tangent is opposite over adjacent. Sorry about that. So that means that if our sign is negative, remember that means that our opposite over hypotenuse has to be negative. But our hypotenuse is always a positive thing, so we need our opposite to be negative. And then the only way we can get a positive here is if our adjacent is also negative. So our opposite is negative, our adjacent is negative to give us a positive tangent. Now let's go even further into this thinking. Remember the quadrants. Quadrant 3 has an x that is negative and a y that is negative. So the only place where the tangent will be a positive thing, because we need an opposite and adjacent to cancel out the negatives, will be in that quadrant. So what we're going to do is we're going to put a point anywhere in that quadrant. It doesn't have to be to scale. We're going to connect it to the origin. We're going to connect it to the x-axis. We're going to put our theta here. And that's our reference theta, but it doesn't really matter. We have to draw our opposite being -5, our adjacent being -12. So we're really at the point -5, -12. No, I'm sorry, -12, -5. Remember, your x is your adjacent, your y is your opposite. So we don't have the r, so that's going to be the square root of -5 squared plus -12 squared. 144 plus 25 is 169. So r is the square root of 169, which is 13. So I know that that is 13. So I know my adjacent is the x value, -12. My opposite is -5. My hypotenuse is 13. Does it fit what we want? Is the opposite over the adjacent +5/12? Yes, because the two negatives will cancel each other out. Is our sign negative? Yes, because it would be a negative divided by a positive. So all those things work out for this particular triangle. So we have found the triangle and the point that matches this information. So what do you need to remember? Well, the cosine is related to our adjacent over hypotenuse. So it is positive here and here, negative here and here. Our sine is related to our opposite or our y value. It's positive here and here. It's negative here and here. So then the tangents, kind of becomes related to sine over cosine and all that good stuff. Okay. Now that we've labeled our triangle, we've got everything ready to go. We know our trig function. So the sine of theta is going to be opposite over hypotenuse, or -5/13. The cosine of theta is -12/13. They gave us that the tangent was 5/12. Is the tangent 5/12? It sure is. Now, it would have been a negative divided by a negative, but negative divided by negative is a positive. Yep. So this one checks out. Is the sign negative? Yes, this one checks out. So as you're doing your 6 trig functions, it better line up with the things that they have mentioned. The tangent is positive and the sine is negative. Okay. Now let's do our other ones, our cosecant, our secant, and our cotangent. Okay. So let's just flip them over. So our cosecant is negative 13 over 5. Our secant is negative 13 over 12. Our cotangent is 12 over 5. Now, technically, you don't have to draw the triangle for this one because we know that our tangent is 5 over 12. So we know the cotangent. And if we think about the fact that that's opposite over adjacent, or y over x, our y value is 5 over 12, just keep in mind that you had to have the two negatives to cancel out and become a positive. Okay? So that's example 2. Okay? Even though they gave us the 512, I write it in there because of the fact then I've got it as reference and I can look back and say, oh yeah, that's exactly what I got. Okay, do we have any questions about example 2? Okay, now let's look at the assignment we've got. On the homework here, these 4, I want you to draw the reference triangles, list the 6 trig functions, exact values, no calculator values, please. So these look like the first 2 that we have done. So these 2 are kind of, or these 4 are the like the first 2 examples. These are like the last 2 examples. Let's just look at them real quick. For 33, think about the tangent as 2 over 1. So if it's 2 over 1, you want to think about this. It's your y value. This is your x value. So the sine and the cosine are both positive. The sine is x over r. The cosine, the sine is y over r. The cosine is x over r. So that means the only place that happens is in this first quadrant where everything is positive. So we have to put our point there. So we know that our y value is 2 and our x value is 1. So this, remember, is always your opposite. This is always your adjacent. And then you just got to go from there. But 34, where would the sign be positive? So where would our y be positive? And where would our x be negative? So that's my hint to you for number 34. Where would the y be a positive, but the x be a negative? And for your cosecant, just like 33, just make it over 1. Because if the cosecant is 2 over 1, I know the sine is 1 over 2. And then you can draw all your stuff from there. Okay? So you have the remainder of class to work on this. So it is due by the time you walk in here tomorrow at the beginning of class, so that if you have any questions, you can ask those questions before you have to turn it in. So it is due at the beginning of class tomorrow. We are going to have memorization quiz coming about the information we're going to do tomorrow. So it is super important that you keep up with this stuff because it's going to keep building upon itself. Okay, so there you go.